Hey everybody, welcome back. So I just want to take a break today to show you something the nice people at Elegoo sent me. They are Elegoo and their website is elegoo.com. They make Arduinos and accessories for Arduinos and all kinds of cool little fun electronic toys and things like that. This is their Super Starter Kit for the Arduino Uno R3. And it has all kinds of different projects and things you can build in it. Before we open the box, let's pop over to their website and take a look at it over there, and we'll see what it looks like. This is their website. They have our opening page has a little penguin bot and their little smart car kit. Let's take a look at their product page, and we will find the little smart car kit looks like it's something that people like me with a 3D printer would really enjoy, because it would be a good little test bed for wheels and tires and different bodies you could print and things like that. But you know, that might be a video for a different day. But right here is the Super Starter Kit that we're looking at. And they show you it's $42.99 US on their website. They show you a nice picture of all the contents and give you a nice list of what's in the box. And here is their Ultimate Kit and their Starter Kit. The Super Starter Kit is right in the middle between the Basic and the Ultimate. So let's take a look, and it comes with a disc that has all kinds of different projects on it. It has libraries and code, and it covers installing. Let's take a look at it real quick. It's over here. It covers installing the IDE software. Again, it shows everything that's in it. It covers here's the different things it can do. Installing IDE, add libraries, and the serial monitor. Then it goes into the projects. We start with Blink. Blink is a simple sketch that just tells the Arduino to blink the LED that's on it. And that's always nice because it confirms that your computer is correctly recognizing the board and the board is responding to accepting, sketches and running them. I always like to do that first, because that way later on, if my code doesn't run, at least I know it's my code and not something even more basic. Then getting the LEDs and the digital inputs and the buzzers and the tilt switches and the servos. All of these come with code and libraries if necessary. Temperature and humidity sensors, the ultrasonic sensor that things like the robot car uses. Temperature and humidity analog joystick, receiver, LCD, thermometer, 8 LEDs, the serial monitor, photo cell, the segment display, the DC motors, the relay, the stepper motor, and using the remote to control the stepper motor. And you'll see it's got really super nice descriptions and photos, and you'll be happy to know that the English in it is excellent. I can't speak for the other languages, but the English is just super good. And you'll find it even covers electronics theory, which is something really good to know. If you've started in electronics and building these things and you've never learned theory, it is always nice to go back and learn it, because you'll really get stuck without it. Ask me how I know that, because that's how I started without knowing electronics theory. So it was good to go back and learn what all the components meant, and that will help you very much here. The pictures and the diagrams and the descriptions are really excellent. And don't know where they sourced this, whether they wrote this in-house, but whoever did it did an excellent job. So now that we've taken a look at that, let's pop over and let's see what's in the box. Okay, let's get this open and let's see what's in it. Before I begin, I do want to say that I have had these parts out of the box before. Elegoo had this packed up super nice, each individual item wrapped, and I knew that was going to take far too long on screen, so I have had it all out. So be aware that as I unpack it, what you're looking at is my packing job, not Elegoo's. I tried to put it back as best I could, but it is not as good as they had it. So let's get it open. And first thing you'll see, we have a little plaque card, and the camera wasn't focusing when I had it on autofocus, so I've kind of put it on manual so that I could hold things up about here to get them to see it. So if things in the box look slightly blurry, that's why. So we have an 18-inch long USB cable. Here is our LCD display, and very, very nice quality. all pins on it. There is no soldering in this kit either, by the way, which is always nice to see. Here is the R3 Uno board itself, and if you've ever been in the Arduinos in the past and you ordered some of the overseas $3, $4, $5 Arduino boards and you saw the quality, you'll be happy to see how super high quality these are. These are just, everything in this is the same quality as this, which is very, very nice. I'm very pleased. Here is the little proximity sensor that the robot cars and the other robots use to avoid obstacles. Here is a little 5-volt servo motor like I bought for my Watchfinder. In fact, probably the identical one. Surprisingly powerful for how tiny they are. Here is a 4-digit 7-segment digital display. I left the styrofoam on the back so I wouldn't bend the pins up too badly. Here is the single-digit 7-segment display. Here is the little power control supply board. This powers from it, and you can use I don't see it, I haven't uncovered it yet, but there's a 9-volt battery in the kit with a connection to connect the 9-volt battery in here, so you're not always tied down to being plugged into the wall or into your computer for power. Then we have a boatload of colored different length jumper wires, and this is beautiful to see because in some of those early kits they'd give you like a half a dozen of these and you need like 20 or more. So these are mostly male to male, but there are some male to female in there as well, which is just really nice to see. Here is the large breadboard for your experiments. Here is a small breadboard if you need to put it in some smaller box. It's always nice to see a small one because those big ones don't fit into anything. Here is some about 20 multicolored LEDs. Here's a little joystick control unit. That's kind of interesting. I've never had one of those for an Arduino project before. Here's a little fan blade with little floppy plastic fans, good for your electric motor project. Kind of harkens me back to when I was first got into Arduinos, when I was trying to make a pulse width modulated fan controller for my Jeep. Might still have that code around someplace. Here is a boatload of resistors. Here's a little remote control, something else I never had with an Arduino project. Here is a little expansion board. Very nice quality, very, very nice. I know I sound like a cheerleader, but this is really very nice. Here's some ICs, some speakers. This is probably the stepper driver board for the stepper motor. Here's the 9-volt battery and the little 9-volt power supply cable. Here is the humidity temperature sensor unit. Here is a 5-volt electric motor, little 5-volt relay, little potentiometer with a dial knob on it. It has a slot in the end for a flat blade screwdriver. Here is your 5-volt stepper motor. Be a fun little project with that. And here is a little bag with some clicky switches, and it looks like there's a photo cell or two in there as well. And that's it. That's the contents of our box. And that is a lot of stuff to make a bunch of different projects. And we are going to come back and we are going to test out this Arduino with Blink, and we may even throw a couple of projects together too, just for fun. Okay, so let's run that Blink sketch just to verify that everything is working. So first thing I'm going to do is plug it in. You'll hear my computer recognize the board. And since this is the computer that I use for the Arduino for flashing the Ender 3, it's pretty much set up. But of course the settings were incorrect. So let's take a look at them real quick. Under Tools, you'll see the board is Arduino Genuino Uno. And if you were for doing the Ender 3, this needs to be set to Sanguino. And the port is COM3 and says Arduino Genuino, however you pronounce that, Uno. And the programmer, instead of the Arduino as ISP, is AVR ISP Mark II. So this is going to work with this board. And that's how you want it set. And those are usually the settings that it will come when you first install the Arduino IDE software. So let's go to File, and then File, and then down to Examples, and over to Basics, and then over to Blink. It'll open up a new window with the blink sketch in it. And the blink sketch is just a single loop telling it to turn on, then turn off the LED and having it repeat that. So it should just blink this little orange LED, little yellow LED, whatever color it is. It's going to blink on and off slowly. So I'm going to click the upload button. Now, if this was a sketch I was developing myself, I would verify it before I would attempt to upload it. But Upload will verify and then upload it. Since I know it works, I'm just going to go ahead and click Upload. And you'll see the progress bar in the lower right-hand corner of the window as it compiles. And then you'll see AVRDude come in and go ahead and send it to the Arduino. And then you'll see the LED is blinking, so we know we have a good connection between the computer. We know we have a functional Arduino board, and now we can move on with some of the other projects. Okay, so let's run another one of the experiments. Let's start with a very simple one, a little bit more complex than Blink, which was, of course, not much anything at all. But this one is the temperature and humidity sensor. It's lesson number 11. And you will see down from here, it is a very simple setup. It is a 3-wire setup, does not require a breadboard. And let's take a look at their instructions. It tells us how it works, gives us what's required, and gives us, the parameters and specifications of the sensor, which is pretty good, really. And it gives us the pinouts, and this is basically a 3-wire connection. And they use red for positive, black for negative, and green for data, which is good, which is what I've always used. And 3 wires, and that's how I've got it wired up. We have 5 volts positive, 5 volts negative, and then we have the data wire over here in the number 2 connection. So let's pop over to my folder with my Elegoo stuff in it. Here it is here. This is what comes on the disk. I have downloaded the one from the website because I'm not a big fan of disks. But anyway, we are going to come into English, and we're going to come into code, and you'll notice there's a separate folder here with all the libraries. This one requires the DHT library, and not the one that you will see if you just go to Arduino IDE and say, hey, add the DHT library. That's not the same one. This is DHT non-blocking. So you'll need to install that. The instructions are in the beginning of the PDF on how to do it. But let's come back to English and go to code and lesson number 11. And there's a zip file in there, and I've unzipped it into this folder. So I'm just going to open it up. I'm just going to double click on the example here. Oops, got to go one more double click. And it'll open my Arduino IDE software since it is affiliated with it. And here we go. So you'll notice it says include DHT non-blocking. And if I come up to tools, and it's not in tools, it's in sketch, include library and manage libraries. If I come to type of all, type 2, I want to put in installed. And if I scroll to the bottom where the ones I've installed will be, you'll see DHT non-blocking. You'll see at first I did not read the instructions, and I put in the regular DHT sensor library, and it did not work. So then I did read the instructions, and I put in their library. So don't be me, read the instructions. And you'll see the code and says include DHT non-blocking. It is again a very simple sketch. We are going to click upload. You will see the lights on the Arduino blink as it's uploading, compiling, then uploading. And it's done. Right? Oh, I click compile, not upload. What a dummy. Upload. Okay, so here it goes. You'll see it blink as it's uploading. It says done uploading. So what happened? Well, not much really, except now that it is reading the data from our little sensor here. And in order to look at that data right now, we have to come into the IDE software, and up in the upper right, this button up here is the serial monitor. It shows the serial data stream. So let's click it and let's see what we get. We should start getting a temperature and a humidity reading, and there we go right there. And I just happen to have a little handheld meter right here, and let's see if they kind of sort of agree. This says it is 16% humidity and 30 degrees Celsius. That says it's 17% humidity and 29. Yeah, I don't know which one is off. This was an $8 meter from Amazon. This is probably a 35-cent sensor, so you know what? You pick. Anyway, that's all that is. This data can then be added into other sketches to trigger fans or whatever else you want to trigger when the temperature or the humidity reaches certain levels. Okay, so now just for sport and amusement, let's try the ultrasonic module out. Again, I have never used one of these before, and I'm just kind of interested to see it. It is a very simple hookup, 4 wires, and again, a positive and negative for the 5 volts, and in this case, a trigger and what they call an echo wire. This is kind of like a bat sending out a signal and listening for it back, and that's how it judges its distance. Or if you're a submarine movie fan, 1 ping and 1 ping only. So, as you can see, I've got it hooked up. Let's go to our Arduino software. Here is the sketch open. I had to put the SR04 library in. Again, it tells you how to do that in the instructions. So, let's upload this. Yep, I got an error message. Nope, I didn't plug it in. Ha ha ha. Okay. There's your problem. Okay, so let's upload it again. Bet it works better this time. Okay, done uploading. So let's open our serial monitor because that's how we're going to read the output of this. And let's see what it says. 21 centimeters. Let's hold it out there. And here I'll use my hand and we'll block it. 2 centimeters. 107. 2. So that's actually pretty cool. That you would, of course, not use it to read out in the serial monitor like this. You would use the output of this to trigger another event, such as a motor reversing or wheels turning or things like that, alarm going off, I don't know. But that's really pretty cool. So I think I'm going to do one more, and I think I'm going to wire up one of the more complex ones, and we will call this review good. So hang on. Okay, so this next little experiment is the one using the LCD display, and as you can see, we're looking at it over here on the tutorial page they gave us, and they give us a wiring diagram, and then they give us this little pictorial diagram, and it's quite a bit more complex than the previous one. What this does is uses the LCD and the breadboard and the potentiometer, and the potentiometer is so that you can lighten and darken the display. And the code has it print hello world on the LCD, and then has it count up a number on the bottom row. And here is a picture example of how the wiring is. And this is what it's supposed to look like. It's supposed to say hello world. I have it loaded in. You have to load in the liquid crystal library, which they provide. I have that loaded in. This is the sketch, hello world, and let's give it a try. And not seeing anything. Oh, there it is. This little potentiometer doesn't fit on the breadboard very well, but there it is. Don't know if you can see it. Let me see if I can get it up to the camera a little better so that you can see it. There, I'm trying to get you to see it. There it is right there. Hello world, and it's counting up. So that's all that is. This one requires a little bit more effort to get it wired right. My first couple attempts did not have it wired right, and of course that was all my fault. And when I finally traced the wires back and got it straight, the breadboard business, when you first do this with the breadboard, follow the example exactly, use the exact holes they use. once you start to understand how the rails line up, you'll know where you can plug it and where you can't. I mean, anything along the 5-volt line is good for positive. Anything along the negative line is good for negative. But until you learn it, follow their example exactly. Okay, I am back, and I think this is probably going to be the last one I do. As much fun as I've been having today with this, I would love to sit here and do every one of them, plus some of my own, but I just don't want to make a video that long, and I'm running out of time today. So now we are going to do the thermometer, and I have that up it's hard to notice here in this picture, but I have added a tiny little thermistor right here. And for those of you who do 3D printing, you'll know what a thermistor is. It reads temperature. I have added a 10,000 ohm resistor here, and I have added 2 more jumper cables. And that is all I have to add from the liquid crystal display setup, the Hello World experiment. So let me find that. Here we go right here, thermometer. It does not require any extra libraries, and let's go ahead and send it to the board. And don't know if you can see, it's reading 29.62 degrees Celsius. And if you look at my little display here, it says it is 30. So 29.62 and 30 is pretty darn close. I'm going to see if I can get this up closer so you can see it. There it is, and I'm going to grab the thermistor with my fingers. And there you can see the temperature starting to climb from the temperature of my fingers. And I'm going to let go, and it should immediately start to drop. And it does. So, gee, that's a lot of fun. This is what I wanted when I was doing the setup for the PWM fan controller on my Jeep. I wanted a readout like this on the dash, along with a light telling me when the fans came on, and an override switch so I could turn them on whenever I wanted to. But the problem was going from a 5-volt fan that uses 1/10 of an amp to a 12-volt fan that uses 50 amps. So that's where I called it quits and went and purchased one. And I wish I hadn't. I wish I had kept it up, but I needed it to work. So that's the end of this review on the Elegoo Super Starter Kit for the Arduino Uno R3. I find this to be a very good kit. I'm very pleased with it. The quality of everything is high. All the components work. They're very nicely made. The instructions and the experiments that you can run are all well laid out, and it even teaches you coding and theory, what the code things mean, you know, what each individual electronic component does and how it works. If you're getting into coding and Arduino and electronics, or you know somebody who is, this would be an excellent kit for them, and it really is very fairly priced. I will put links below, and I hope you've enjoyed this video. Please like and subscribe and hit notifications, and I will catch you guys the next time. Have a great weekend. Bye now.